All right, welcome back to episode 8, part 2 of the Hack Week, Grow Week batching optimization. This has been running for like literally 10 minutes since the last episode, and you'll notice that we've already fallen out of sync with our grows and our weekends. This is common. This is going to happen. I'm not sure there's any way you can prevent this, but the problem is it falls more and more out of sync on every iteration. So there's two things we're going to change to fix that. First thing we're going to do is when we're calculating the threads, we're actually going to calculate, instead of just say hack threads minus divided by 25, we're going to say plus any additional threads we may need to bring this back in line with 0. Which is this guy up here. And we actually don't need to seal this twice. And we're going to modify the grow threads. Instead of using target money max times 1 minus hack percent, we actually use target money available. No, we're going to use max. Hold on. Let me wrap my head around this. Hack threads is using max times hack percent. Here, I'm just going to do it like this. This will be easiest. Right, so I'm going to reverse these so that it'll first grab how much we need to just bring it back in compliance, and then it will add to that the extra threads we'll need after hack threads completes. So it's still going to do its early prep of going through the grow and then going through the weekend to fix it to start with. But the question is, will it fall out of sync later? And I believe that singular change will prevent it from falling significantly out of sync, though as we make this more complicated, it's not going to be enough. Second thing I want to change, and we're just going to let this run and see if it falls out of sync again, is I want to distribute weak threads. So distributed batching is when you have multiple servers all attacking the same target. You can't distribute hacks or grows because they operate exponentially, but you can distribute the weakens because they are always one weakened thread reduces the security by 0.05 or whatever. So if you distribute the hacks and grows, you'll get completely wrong numbers on everything, but if you distribute the weakens, you're fine. So instead of doing this here, this calculation, I'm going to say I'm going to iterate through the servers and say if server.ran.free is greater than proposed batch.week1, then do something. I'm actually going to continue. There's a better way to do this, and I'll show you later. And what that something that we're going to do is we're going to use this next batch array that we set up and we never used. And we're going to push to it an object that has attacker I guess it's, yeah, 40. And so what this is going to do is it's going to tell us in next batch, when we go through that array, we're going to know that the next batch has this person attacking with this file at this time. Just for clarity, I'll give them different names. I'm going to do the same thing down here, except this lands at 120. And then I also need to do the hacks and the grows. And we will only push those if home has sufficient RAM to run the hack and the grow. So let's go through the pseudocode now. The prep is working like standard. Then when we get in this like kind of permanent batching loop, we're going to calculate the number of threads we need. And calculate the times. Calculate a next landing time, which is 3 seconds plus now. So in 3 seconds, it will be the time when it lands. Then we're going to set up an array to which we are going to push an object that looks like this with 3 properties: attacker, file name, and landing time. And if it's a grow or a hack, we're going to sum those values and make sure we've got enough RAM to do both the grow and the hack. And if we do, we're going to push next batch is going to get that object. Then we're going to iterate through the rest of our servers, including home. Home still counts as a server. Then we're going to say if the proposed batch has weakened threads that it needs, which as of now it always will, and the server can handle the entire weaken, we're going to push the server ID with the file name weak, and we're going to land at that time. So ideally, next batch will have a length of 4. If any of these fail, next batch will not have a length of 4. And so we'll know that we can't fire all of our scripts at once. So far, this hasn't fallen out of sync yet. So that's a good sign. I'm going to let these complete. Something's wrong. So next batch is very long. It's not 4, it's like 16. The reason it's so long is because I think our continues are broken. But I was going to fix this in kind of like the next iteration of this, but I'm going to go on and do it now. We can set those to 0 and then it won't push for the next server. That's 4 long. But using proposed batch down here still. What we want to do is use next batch. That's not how we want to do it. How do we want to do it? Let's see what we're actually sending. Okay, so we need to restructure this entirely. Because next batch has like all of the information in it we need. We'll just do for let command of next batch. Now we need the threads. Still target ID, still false, and then we want to use command.landing. Right, so all of this information is now stored in our next batch array. So we don't need to specifically define it. Okay, so let's kind of prep noodles again for some reason. And what we're hoping to see after this is done is exactly what we do see. The hacks and the grows ending up on home, and weekends ending up on a different server. It'd be even more efficient if we didn't do any weekends on home. But we also don't want to lose batches because our other servers don't have enough weekends. So the simple fix is to just resort our servers. So that the last server considered when it's going through this for let server of servers, wherever it went, this, we want home to be the last server considered. And I think we can do that by saying Just going to test that before we go too far. There we go. Home is the very last server. Done. All right, so now home only has hacks and grows, and the other servers have the weekends. And the timings look pretty good. This hack, well, kind of hard to trace. Easiest way to trace is to see if it falls out of sync. The reason why it's not firing another batch immediately is because there's no more space on home. That did fall out of sync. May increase this by just a hair. Personally, I don't see any reason why this should be falling out of sync. Oh, it didn't fall out of sync. It just got killed. No, that's definitely out of sync. So 50.501 is our baseline. That grow is at the perfect time. There should be one at 541, yep. One at 620. But there's not one at 620. Oh, I know what's happening. Servers are being, like, if a server has enough to do week 1, it will also have enough to do week 2, but that command will not have fired yet. so it won't be like it's trying to double fire. Basically, there's not enough RAM on the server to do both week 1 and week 2, but thinks there's enough, but there's not enough. The way we can fix that is to make a map. Way up here, iterate through the servers. And set the amount of RAM that's free on it. And then anytime that a next batch is pushed, since required RAM is already the sum of both of these, I'll just do it like this. Home's never going to be the problem, I don't think. And here, available ram.set server.id. We're basically just subtracting the required RAM for this batch from available RAM. And instead of doing is greater than server RAM free, we'll do available RAM get. This is like a temporary store of how much RAM there is. And we need to recalculate yeah, that should work. All right, we got 6 batches going and 10 weekend operations. No, we don't. We have 5 batches going, 12 threads, minus monitor and the main thread. 1, 2, 3, 4, 5. That checks out. That's 2 weekends for every hack and grow. Times look good. 046, which means you got one at 086, which is was there. And we didn't desync. Except that we did desync. Maybe the problem is in this sleep time. I'm wondering if at the end of the day this even matters, because we've got all the calculations to fix broken batches. But you might as well get it right when it's so simple. Yeah, that is the accompanying week for that grow. But there's an earlier one. Oh, that's for the hack. Yeah, those two things fired before this one did. I think the math error is in these. I think it's this right here. Sometimes when you're subtracting, if you do it like this minus this minus this, it can be weird. I'm just going to change this one thing because I've seen it be weird before. All right, that looks better. Let it run through one more loop. Yeah, that fixed it. Okay. Or did it? I don't even know anymore. Well, as long as it doesn't get so out of sync that we end up with 0%, I'm going to leave it like that. Because the next thing I'm going to change is we've got some inefficiencies here. This requires the server to have enough threads to cover the weaken operation. When, while that might be sufficient, that's not really necessary. Instead, if there's not enough threads, we are going to push another batch. We're just going to use whatever threads we have available. And then subtract that. We probably don't even need this. Yeah, I'm going to leave it like that. It's more accurate. And then instead of just setting to the weak threads to 0, I'm going to say All right, so we're setting up another object called batch, and we're just pushing that into the next batch so that we can do math with it later. That's all we're doing. And so if we need 10 threads and we've only got 3 available, it'll just subtract those 3 from proposed batch. And then on the next iteration through, this will still be greater than 0, so we'll try to fill it out again. But unfortunately, this no longer is accurate because it's going to be, it could be 8, could be 15 long. So instead we want to say if next batch reduce no, that's not going to do it just yet. We have to filter the batches by batch.filename. Then we can reduce it. And we'll compare that to weak threads 1 plus 2. And we'll say, I don't know if we should say equals or greater than or equals. I think we'll go with this for now, and if we have problems, we'll adjust it, because there may be like an extra thread. I think there will always be an extra thread. Maybe not. We'll know if nothing fires. Don't need that. Really should fix that weird calc error where my weakened threads are wrong. I'm pretty sure that math is right. Well, we know it's the reduce is wrong because nothing's firing. See how wrong it is. What? Oh. That's what we actually want. Oh. Okay. Well, it's telling me that I need 16, or I'm getting 1615 threads. Why? Like everybody's trying to get threads in. Some of them are getting 0 threads. Oh, okay. So this needs to be broken out. Now it's telling me I need 26 threads. I'm not even sure if that's accurate. It's telling me I'm getting 26 threads. Oh, it's not filtering the file name. Duh. Perfect. Something happened there. Invalid thread count. Okay. Somewhere in here, 0 threads are getting assigned. Fairly sure this math is wrong as well. Should not be 1 thread for weaken. Or sorry, for grow. Wonder if maybe this is resolving to a negative number or something. Shouldn't be. Oh, crap. So slow. Okay, that looks good so far. And the timings are correct. Maybe my weak threads are incorrect. Well, whatever we did fixed it because it didn't desync. And things are getting split up appropriately. And that's a distributed batcher. I'm going to let this run for a couple more minutes just to make sure, but I think we can delete all of our T-prints. Oh, we lost one. No, we didn't. Came back for us. Yeah, that's looking good. That's about as efficient as we can get. The only way we could make this slightly more efficient is letting any server do the hack. Might as well go in and do that and then just call it a day. So we're going to structure that the same as this right here. Except we're not going to have this partial hack statement. Because the hack has to be carried out on a single server. It looks like the issue may be with my monitor application. So I know that there's a command, refresh. Refresh rate. So by default, the monitor updates every 200 milliseconds. This will make it update 1 millisecond, so it'll be instant. Oh God. So nobody got the hack. Why did nobody get the hack? Oh, because I set it to 0. Duh. Um, make sure it's saving, because it looks like it should be picking up the hack just fine. Looks like home should be picking it up. Home is not picking it up. Oh, let's grow threads. Keep it standard. And we should probably also improve our sanity check to stop deployment if we are not able to get hack, grow, and weak. So right now it's checking to make sure we've got enough weeks. It's also checked to make sure we've got enough grow threads and hack threads. Not the most elegant solution, but good enough for the girls I go out with. Well, nobody's picking up the hack. Must have a syntax error. Oh, okay. Alpha int is trying to pick it up. Well, that's going to be a problem. Actually, I can just do s.isAttacker. That's a function on our new server object. At least I thought it was. Huh, I never added it. Okay, so we just need to add a couple of functions here. Is target and is attacker. And I'll probably go in and add PIDs because I use PIDs. And I get another function I like called targeting PIDs. These are the processes that are currently targeting the server. So if I want to kill all the processes targeting food and stuff, I just say food and stuff.targeting PIDs, kill all. Much better. So Home's picking up the hack. As we suspected, because the hack is so big that no other server has the available RAM to pick it up. But if we were to buy a purchase server, it would have enough RAM to pick it up. And I think that'll do it for a extremely efficient distributed batch HWGW. We're coming up on an hour, so I'm definitely going to cut this off in the future. Not going to be next episode, but several episodes in the future when we get quite a bit more RAM on our home. We'll have to come back and modify the script to attack not just noodles, but any target, because eventually we'll have too many threads going against noodles. So if you think about it, every script is separated by 40 milliseconds. And if you have scripts deploying every 40 milliseconds, and then you need to fit another script in there because you've got, 600 scripts deploying, you're going to have a problem. So what you do is you set a maximum for noodles, and you say, when I hit that maximum number of scripts, move to food and stuff. But we're not there yet. We don't have nearly the quantity of scripts running. We're running 5 batches. So I'm not going to worry about that right now because it adds quite a bit of complexity, and it has been an hour. So I appreciate everybody sticking with us as we debugged this. The source code will be up on the website on GitHub. It seems fully functional to me, so feel free to rip it and use it. All right, see you in the next one.